Hi, my name is Carly Rundle, and you are listening to the Hans H. Stein Monogastric Nutrition Laboratory podcast. Today, I will be presenting my poster from the 2022 Midwest meeting of the American Society of Animal Science in Omaha, Nebraska, titled Isoquinoline Alkaloids Improve Intestinal Function of Weanling Pigs Fed Corn-Soybean Meal Diets Formulated Below Amino Acid Requirements. Previous findings have indicated that addition of isoquinoline alkaloids, or IQ, to diets fed to swine increases the apparent ileal digestibility of amino acids by nursery, growing, and finishing pigs, thereby increasing the bioavailability of amino acids in the diet. Furthermore, improvements in intestinal health have been observed, including a reduction in neutrophils, increased transepithelial resistance, and morphological improvements such as an increase in villus height and a decrease in lamina propria thickness. It has also been reported through numerous studies that reducing crude protein in the diet results in improvements in intestinal health as well. Therefore, it was the objective of this experiment to test the hypothesis that IQ fed to weanling pigs in diets formulated below amino acid requirements would improve intestinal health and maintain growth performance. There were 2 phases in this experiment, with phase 1 lasting from day 0 to day 14 and phase 2 being from day 15 to day 27. Within each phase, there were 4 dietary treatments, starting with a controlled diet based on corn and soybean meal and formulated to be at the amino acid requirements for pigs in both life stages. The second diet was formulated to be based on the control diet, but with the addition of 120 milligrams per kilogram IQ. The third diet was formulated to be 10% below amino acid requirements for each phase of the experiment, and the fourth experimental diet was based on the third diet so that it was also formulated to be 10% below amino acid requirements, but also had the addition of 120 milligrams per kilogram isoquinoline alkaloids. 200 pigs with an average initial body weight of 6.11 kilograms were allotted to one of the 4 dietary treatments for the entire duration of the experiment. Individual body weights were collected on day 14 and day 27, and feed intake was calculated for phase 1, phase 2, and the overall experimental period. Plasma samples were collected on day 14 and 27, and ileal and jejunal samples were collected from 1 pig per pen on day 27. Setting up the graphs, we have the orange bars representing the positive control groups formulated at amino acid requirements, and the navy bars representing the negative control treatment groups formulated to be 10% below amino acid requirements. The stripes on the bars then indicate the inclusion of IQ to the diet. There was no effect on average daily gain by reducing the amino acids in the diet or including IQ. However, average daily feed intake tended to increase when IQ was added to the diet. Additionally, gain-to-feed ratio was reduced when diets were formulated below amino acid requirements compared with the positive control diets. Villus height tended to increase with dietary IQ and also tended to increase as amino acids were reduced in the diet. However, an interaction between the two was not observed. Lamina propria thickness was not affected when diets were formulated at amino acid requirements, but when diets were formulated below amino acid requirements, lamina propria thickness was reduced with inclusion of IQ to the diet. Expression of occludin, a tight junction protein in the intestine, was not affected when diets were formulated at amino acid requirements. However, when amino acids were reduced in the diet, dietary IQ tended to increase occludin expression, indicating an improvement in intestinal barrier function. On day 14 of the experiment, when amino acids were formulated at requirements, interleukins 4 and 10 were reduced when IQ was added in the diet. But when amino acids were below the requirement, IQ did not influence concentrations of plasma interleukins 4 and 10. Reducing amino acids in the diet reduced TNF-alpha in the plasma and tended to reduce interferon gamma and interleukin 2, indicating that reducing amino acids in the diet does in fact reduce systemic inflammation. In conclusion, when amino acids are provided below requirements in diets for weanling pigs, dietary inclusion of isoquinoline alkaloids modulates systemic inflammation and improves intestinal function, as observed by the changes in cytokine expression in plasma and tight junction proteins in the intestine. Thank you so much for listening. If you have any questions or want to learn more about our research, you can email me at rundle2@illinois.edu or visit our website at nutrition.ansi.illinois.edu.